It is a good practice to save your model. So we'll save our it is a good practice to save our model. We will save our model. Okay, and as I have file save as, and you can save by, right now I have saved by 3df.sdb, but you can save by any other name. Okay, so now switch back to classic view. In the classic view, select by properties. In the properties, select frame section. In the frame section, I have defined this frame section. Select all the frame sections. Assign frame section. I want to increase the depth so that I can see connectivity 24 cross 15. Now looking at 24 cross 15, let's zoom this model and check our connectivity. Here the slab is not connected by the top. Okay, the slab is connected from the slab and beam are connected by the center line. Got it? So you can confirm this because there is some clearance which we can see here. Okay, so if you can see from the bottom, you will see this more clearly. See, from the bottom, if you see, the slab is the area which is appearing, which is offset from the slab, is this thickness is the same as that from the top. So the slab is connected from the center point of the beam. We need to change this because in our model we have a T-beam system in which slab is connected over the top and beam is on the bottom. Okay, now go back to the 3D view and select again, select your property and select the frame section which we have right now assigned 24 cross 15. All the frames are selected. Assign frame insertion point. Insertion point control the connectivity of the slab with connectivity of the frame with the slab. Right now it is centroid connectivity. I'll convert this to the top center, which is number 8. By top center it become a T-beam system. If I connect by the bottom center, it become inverted T-beam, but right now I will connect it from the top center. Press OK. Now check the connectivity of slab and the beam with each other. If you focus, the slab is now at the top, and if we rotate this a bit, we can see it, the slab is at the top and the frame is connected from the top to the center of the slab. Okay, and there is no thickness of the slab because it is a 2-dimensional element. Thickness is defined only in the formulas. Got it? So all the web is now right below the top of the slab. Now this is the model which we need. This is what we need. So this point is very important when you make a slab beam system in which you consider the T-beam is below the slab. This is, now let's go back to our model. Next step is to define the, we have defined the sections. Now we need to define load cases and save our model as well. Define load pattern. In the load pattern, define a live load, add type as live load and add this pattern. Press OK. Now define load combination. Add default design combo, and the combination is based on the concrete frame design. Right now we have a code of ACI 31805 along with IBC. So the combination of the concrete frame design will be based on ACI code in IBC, which is for the dead load we have factor of 1.2, and for the live we have a factor of uh, 1.6. IBC stands for International Building Code. So in UD con 1 we have 1.4 of dead, UD con 2 we have 1.2 of dead, 1.6 of live. Select this, modify and show. Dead is 1.2 of factor and live is 1.6. Press OK. Combinations are made. Now what we need to assign our loading to different slab. So in our model we have a UDL acting on the slab. Go to the plane view, XY. This is the bottom floor, first floor. Press this undeform button. Now go to the topmost floor. The topmost floor is 78. Okay, select this slab, and I want to assign this floor into a group. Assign to group, add a new group and make it as top floor, so that in the future I have easy in selection. This is the top floor. Now go to again, this is the first floor. So I'll select this, assign to group. The group help in selection, and add a new group and name this group as first floor. Okay, and in between the floor are named as intermediate floors. So go and select intermediate floors, and assign to group, add a new group, intermediate floors. Okay, got it. Now go back to 3D. I want to select the top floor. So how I will select and select by the group, and top floor is selected along with the slab. Now assign area load, uniform shell. When I say in selection, I have beam and slab, and I am applying load to area. So load will be applied only to area, not to the frame or beam. Why? Because the load is going to the area load. Although in selection I have both frame and area, but because I am assigning load to area, load will be assigned to area only. Now in the pound foot, how much is the dead load at the top? At the top we have a dead load of 20 psf. Make it 20, and remove the extrusion in the view. So we have a 20 in the pound foot, we have 20 in the acting in the gravity direction. Go back to the previous selection, assign area load, uniform shell in the type live, and in the PSF select a load of 30. Okay, now we'll select intermediate frames. Select properties, select, and we will go to the group, and interfloors. Intermediate floors are selected. Assign area load, uniform to shell. Dead load, in the dead we have, in intermediate floor we have a dead load of 25 pound psf, so make it 25. So intermediate are offered by 25. Now go back to the previous selection by this button, assign area load, uniform to shell. Assign area load, uniform shell, and make it live load, and live load of 40. 40 psf. Now select the bottom, select group and first floor. In the first floor we have a dead load of same uh, we have a dead load of 25 and a live load of 80. Now it's again time to save your model. When you progress to certain extent, you should save the model because it's very important. Our model is we will change back the section of the beams back to the smaller section, which is 12 cross 10, because we changed the section to see the extrusion and the proportion of our member. So change this back to the 12 cross 10. Select properties, frame section, and 24 cross 15, and assign frame section to, 12 cross 10. Now section of the beam is, we have selected minimum section of beam and column. Our model is ready for analysis. Run the analysis. Dead and live will be run. We don't run model case because our analysis is static. Do not run and press run now. Analysis is complete. Check for warning or error. There is no error in our analysis result. So now this is the deform shape. Here we are looking at the mesh. This mesh was not in the model. This mesh appear after the analysis because this is auto mesh, and we have 6 in the x and 6 in the y direction. Remember, the maximum deflection occurs at the mid span and exterior panel of the mid span. So we will check the deflection, but for the service load, so we need to unlock the model and define a service dead and live load combination. Add a new combination, name it as SDL, and dead is there, live is there, so service load we have defined. Run the analysis. This is serviceability requirement for deflection. You can check the deflection by this button and go for SDL case and plot displacement as contour along the Z direction. Z is the vertical direction, global vertical. Press OK. So we will have a contour of our deflection. So our deflection move from in inches, we have a deflection of 1.68 inches to 0.12. Okay, record. Now our model is analyzed, and for the service dead load we have a deflection of 1.68 inches. Okay, record. Now we need to change our deflection is less than, I need the deflection less than an inch, or at least equal to 1 inch, not more than an inch. So I have to change the thickness of slab. So unlock the model, define section, area section, and add a new section. This time the section will be 10 inches. Slab 10. 10 inches is 0.833. Again 0.833. 833. Press OK and OK. Now select all model, assign area, section and slab 10. Okay, I have selected all model including frame, but the section is assigned only to area because I have said assign area section, so it is only assigned to area. Now rerun the model. And check the deflection. The deflection is minus 665, minus 65. Let's check the units. Is basically minus 65 into 10. Okay, the 10 inches slab is not okay. We have defined 10.833 inches, so we need to correct this. Unlock the model again. The units were not correct. Inches we have. Define section, area section, slab 10, modify and show. So it is inches, so inches it should be 10 here. Press OK and OK and run your analysis. Again the deflection is more. Okay, so we need a further increase of the thickness. Okay, so unlock the model and go back to define frame section, area section, add a new section, and we also use the shell thick because the depth is now more. Slab 15 and the thickness become 15. Okay, press OK and OK. Select your all model, assign area section and go for slab 15. Run the model. So we have a more deflection here again. So go back and check the contour of your deflection, or we should not go for contour and press OK, and we should click by our own. Okay, so the deflection usually 1.2, so this is a lot more deflection. So you can control the reflection by increasing the thickness. That's the only way. For this movement we will keep this area section and this, and we will allow the deflection of this much, and we'll further move on. ACI requires serviceability requirement, and serviceability requirement your deflection should be less than 1 inches. Okay, now to to change we have still problem. We are increasing the depth of slab, but our deflection is not under the control. What to do with this? If we increase the stiffness of the column, the dimension of a column, so this problem can be eliminated. The other way around is to increase the material strength. So first of all, I'll go back. uh, I'll select properties, frame section, and I'll select columns, and I'll convert those column to assign frame section into column 15 cross 15. Increase the dimension of the column, and right now as a column dimension increase, stiffness increase, I can use the less section for the slab. So select all, assign area section, and slab 10. I can use 10, I can use 12 as well. So for the time I will use the 12, and it is dimension is defined here in the window. Press OK, run the analysis. Now our deflection is minimum deflection is 0.82, less than an inch. So our model is okay from deflection control point of view. Serviceability requirement are met. The next step is to we can see the forces in the frame. Let's see the shear force for combination 1.2.1.6 of life. Go to XZ view, and you can see the value of shear force in different panels. YZ view, we can also check the moment. And we can check the movement in the slab as well. This is the movement in M11 direction, and where M11 direction correspond area, local axis. The local axis red is pointing in along the global axis, so M11 is along this direction, and steel will be placed in this direction for M11. And for M22 it will be this direction. Let's check for M22. M22 will be placed in the other direction. This is the M22. Now you can check for the concrete steel, concrete design AST11. This is the steel area in inch square per inch along the X direction. We are looking at the top steel, but here we have the bottom steel. Zero steel at the top, and on the bottom we have 0.02 inch square per inch. The design of the frame, including column and beam, has been done in separate videos. Even we have designed the slab as well. So right now we will perform the we are not going in detail design. We only want to perform the check that our model is okay for given dimension and strength or not. So first we will save our model, and then go to design, concrete frame design, view revise preference. Code is ACI 31802 and IBC 2003. This is by default, this code is there. Go to design, select design combo, select also service load, and design, concrete frame design, start check design. The frame element is now designed. Okay, Slab is okay in dimension and thickness. Slab is designed by our own. Now go back to design, concrete frame design, verify all member pass. We have 70 concrete member failed. Let's see them. So our beam, some of the beam and the columns are failing. The bottom column is failing and the intermediate floor beams are failing. So column or 2, 3 stories are failing here with us. So firstly we would like to see how to pause. So let's check this column, and if and go to override. In override, go to section, and in section, the column section, I'm going to increase from 15 to 18 cross 18. This one is for 18 cross 18. Still it is failing. Go back. It is failing longitudinal reinforcement. Overwrite and change this column to 24 cross 24. So in 24 cross 24, these columns are passed. Now we'll select those columns which are failing, or I want to have a simpler design. I'll select all the columns which are failing. Now let's see which beam element are passed and on which steel area they will pass. This is very important to know. Design, concrete frame design, start check design.